Good afternoon. We are going to finish up 3-1, the midpoint formula, and if you have any questions on the homework, we're going to go over those as well, because some of them were a little kind of thought-provoking questions. All right. So how are you guys on the homework?
I had one question.
Good. What is that?
It was 4x equals 3y.
Okay. Let me get into our class, and let me open up this. Okay, do you remember what number that was?
I could look quick.
Sure, Amanda, that would be wonderful. Any other questions that you guys have? 15, says Jessica.
Yep, it was 15.
Okay, 15. So let me get that, and we'll just do yours. Okay. Homework 3.1, number 15. All right, Amanda, go for it. What does it say?
4x equals 3y.
Okay, and then it says basically to graph it, right?
Yep, use the intercepts.
Oh, using intercepts. Okay. So with intercepts, you can either do a t-chart. With your y-intercept, you let x equal 0. For your x-intercept, you let y equal 0. So that's basically what they're asking you to do. So then over here, and this is where it gets a little tricky, you have 4 times 0 equals 3y. So what does y equal? 0, right? Okay, so we got that answer. Now, if I put 0 in for y, what do I get for x? Same thing, right? So these are really the same point. So the x and y-intercept is the only spot where the x and y-intercept will be the same, which is 0, 0. So when you graph it, how are you going to graph it? You just can't graph a line with just one point. So how do you do that? What's a suggestion on how to finish this problem? Here's your red point. Here's your green point on top of it. We can't possibly draw a line. So what should I do next? What should I do next? When I call your name as we're going, go ahead and change your color to green. Lacey, Derek, Sarah. Danielle, Jacob, Melody. Okay, and I'll keep going. Okay, now, 3, 4. So what did you do, Jessica? That's the part that we need to figure out. What did you do? And just interrupt me. I'm just going to keep taking roll, but go ahead and talk over me. Scott Mateski, John Matthews.
I just used the points, 3x, and then 4y. Okay,
so did you just choose another point?
No, I went up 3 and over 4.
Okay, so what you're doing is, I can write 3.
Kind of flipped them, but I don't understand why that works out.
It's the slope-intercept form, which we're going to get into today. But if we don't know that yet, I would just choose a point. And one point could be 3. So now I'm going to do the work down here. 4 times 3 equals 3y. 12 equals 3y. Divide both sides by 3. Y equals 4. So 3, 4 would be here. That is a point on the graph. Maybe not everybody chose that point. But you would choose 0, 0 and another point 3, 4.
I can't see your work right now.
Thank you for letting me know that. Okay, sorry about that. So what I would do, for all we know right now, is the t-chart. T-chart or x-intercepts. This stuff we're actually going to learn later. It's in the form of y equals mx plus b. That's what you have here. but we didn't go over that yesterday, so I didn't want to mention it today. Okay? Good question. Any others from the homework?
Number 14.
14.
It's similar.
Okay. Oh, it's similar. So what does 14 say?
(4x plus y equals 0) is the intercepts to graph it.
Okay. So again, on something like that, what you want to do is you want to, for the intercepts, plug in 0. And if it creates 0 for the other one, you're going to have to choose some other point. And then you just pick it. I just happen to choose 3. You could choose 1. You could choose different numbers. Okay? And I can help you with that one after class, but it's a very similar problem. You're going to have to just pick another point. Okay, how about another different type of question? But good job on that. Are you guys okay on the midpoint?
What is that question when you have to do like x1 minus x2 divided by 2?
That's what we're going to get to today. So let's just recap from yesterday. That's a good question, Lacey. So from section, that's a symbol for section 3.1, they're going to ask you for midpoint. And the midpoint formula is capital M, beautiful capital M, is equal to x1 plus x2 all divided by 2, comma, y1 plus y2 all divided by 2. Okay, so that was what you were supposed to have read yesterday. Now, Lacey asked a different question, which we're going to get to today, and it's called the slope. The slope is little m, and that's just standard across the board. You always do little m, and then it's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and that is what we're going to do today in class. So section 3.2. This is not, it's good to have them side by side so you don't get them mixed up. Okay, now where are we getting all, is that what you're referring to, Lacey?
No, actually the one to the left I was talking about, but
okay.
yeah.
Yep, so those are two different formulas to find completely different things. And please don't change your color to green unless I've called on you. So please turn it back to a different color besides green unless I call on you, or you will be marked absent. All right, now, where are they getting all those x1s, y1s? So basically, okay, you have a line. A line has points. Go ahead, take notes on this. Has points x1, comma, y1. And x sub 2, comma, y sub 2. Now, if I were to draw a picture over on the side, here's your x-axis, here's your y-axis. It doesn't really matter where these points are, but maybe I have a point here. Let's call that my first point. And what some people would do is actually say that's point 1. And then I have another point over here, let's call it point 2, and then that's why you have your x sub 2, y sub 2. It just means it's another point. Okay, so you've got your point here, xy, and you have your point here, xy, but it's the second point. So if I connect these points, I can find what is called the midpoint. And the midpoint is a point right in the middle of this line. That is called capital M, if I could write correctly. So when you're doing that for your homework, it wanted you to find that point that's right in the middle. So it is going to be something, comma, something, because it's a point. Now for slope, slope is dealing with the slant of the line. So if you're looking at this line from left to right and it's going down, your slant should be negative. Your answer would be negative, fraction. If it's going up and to the right, your answer is going to be positive, and there's other things to that. Okay, so let's do an example. Let's say I have a point. Point 1 is going to be, make it look kind of close to the picture. -2, comma, let's do 4. And the second point over here is going to be, let's make it kind of dramatic, 5, comma, 2. So I've got these points over here, -2, 4, and 5, 2, and they want you to find the midpoint. So what you do with the midpoint is you take the average of the two x's. So you add -2 plus 5 divided by 2, comma, take the average of the y's. So you have, in this instance, 3/2, comma, 2/2, which is 1. That is the midpoint. Maybe I should have done that in orange. But that's the midpoint. We're going about 1.5 to the right and up.
How is that 2/2? It's 6/2.
Thank you. So that should be what then?
3.
Good. I want to warn you guys today, I'm going to turn off my video, but I don't know if you can see my eyes. I am so tired today. So if I make a mistake, like Lacey pointed out, just like Lacey did, just interrupt me, okay? I don't know what's going on with me today, but I'm like exhausted. I don't know if you guys are too, but whew. Okay, now the slant.
I'm pretty tired too.
Are you? Yeah, I don't know what's going on. Now the slant, so that's the midpoint. That's what you're supposed to do yesterday. So go over 1.5 and go up 3. Yeah, that looks about better. Now the slope is you're going to subtract your y's. So I'm going to take, this is my y2, which is 2, minus my y1, which is 4. In the denominator, I'm going to go back to this one, which is 5, subtract this x, which is -2. But be careful that you write -2. So what some people do is kind of put like a template of parentheses, subtract your y's in the numerator, subtract your x's in the denominator. So you get 2 minus 4 is -2, and 5 minus -2 is 5 plus 2, which is 7. So this would be my slope, and like I said earlier, it's a negative, and it should be negative because you're going down. You're going down from left to right. Okay, so do you see the difference between midpoint, capital M, and slope, lowercase m? All right, so that's kind of an intro to what we're going to be doing today as far as slope goes. So in section 3.2, it's going to ask you to find the slope of a line given 2 points on the line. Okay, there are different ways to find slope. So the first way is to find it using 2 points, which is what we just did. Then they're going to ask you to find the slope if you're given an equation. Then they're going to go kind of a different direction. Now they want you to graph a line given its slope and a point on the line. Yesterday we graphed using T-chart, or wasn't it intercepts? Okay. And then we have different ways to graph a line. Okay, now they're saying a slope and a point on the line. So we're going to go over those. And then we're going to talk about if lines are parallel, perpendicular, or neither. We'll talk about what that means. And then slope a lot of times is referred to in word problems as the average rate of change. When I teach calculus, we actually do that. And it's actually the first derivative. So if you ever get to calculus, you'll see it again. This is a picture in the book that talks about why the slope works. You can look at it over on your own. But I am going to, well, let's look at the slope here. Write this down in your notes. For slope, you usually use lowercase m, and some people say rise over run. Right? That's one way to think of it. So if I look at this point to this point, I'm going to rise so much, and then I'm going to run so much. Rise is up or down, and run is right or left. If it's positive, it's right. If it's negative, it's left. If it's positive, you go up. If it's negative, you go down. Okay, that's rise over run, essentially. Then over here, they're talking about change in x. So what that is, change of y sub 2 minus y sub 1, over x sub 2 minus x sub 1. That's the famous formula for slope if you're given 2 points. And some books will actually say it this way, change in y over change in x. That is what this means. Okay, they'll just kind of get a fancy way of saying that. Now, examples of slope or a line rising from left to right. That would be an example. That's going to have positive slope. Falling from left to right will have negative slope. Horizontal. Does anybody know what a horizontal line has? What kind of slope? It's actually 0. And vertical line, does anybody know what vertical line would be then? What the slope of a vertical line is?
Undefined.
Very good, very good. Thank you, John. And I can't spell it all out, but it's undefined. So on the next slide in the book, they have all of this. They all have it on one picture, but I don't like it. Sometimes it is a bit too messy. But if you notice, the green line is slope 0, it's horizontal, and the blue line is vertical, that's undefined slope. Undefined could mean like an empty set with a 0 with a slash through it, so don't confuse that with 0. So get used to your zeros without a slash. Okay, so just kind of be careful on that. Okay, now, they are going to give you some other things about slope, and I want you just to think about it. Think about it. So read the first one on your own while I keep taking roll. So I was at John Matthews. Okay, Brad Nelson, Natisha Nelson. You guys were both here yesterday, right? Okay. Karsten, you were here yesterday, and Naomi? Okay. Amanda and Jessica, you were both here yesterday? All right, Amanda, you can change your color to green. And Isiosa, go ahead and change your color to green. And I don't have you here yesterday, Isiosa. Ella is not here. Emma is not here. Nate Hicks is also not here today. All right, and then John Jerichowick was not here today. I don't think he was here yesterday. Melody, were you here yesterday? What about you, Melody, yesterday? Okay. Thank you.
Mrs. Parker?
Yes.
You know how it has rise over run like that?
Right.
You know how it goes to the right, it goes, rises up and then it goes over to the right. What if it goes to the negative?
Okay, we're going to discuss all of that. So we're just kind of starting out slow, and I'll give a whole bunch of examples today, okay?
Okay.
Perfect. So if you had this rise over run, I like how Lacey said rise over run, what would you say for your rise? -20 because of the word drops. For every horizontal of 15 feet, they are assuming that if they don't say anything, it's positive. Now, in my math lab, you want to simplify. So what does that go to? -4/3, correct? Okay, so that's how you want to write it in my math lab. The negative can be either out in front or to the side, like what we were saying before. Okay, now here's one similar to the homework that you're going to, I don't remember if it's 2 or not, but it is a homework. Okay, so it says here that the slope of the roof is 1/3. So again, it's kind of like comparing its rise to run. That's what the refraction would reduce to. But here is your rise and your run. So what would you say, and this 21 feet could have been over here. Okay. What would you say X is? How would you figure that one out? I'm curious what you guys would do. What would you do? Okay, I need a little bit quicker response today, or we're probably not going to get through the lesson.
Would it be x times 21 would equal, or?
Okay, there's different ways. There's different ways. Okay, good. I like the x over 21 because you have rise over run. That's your rise, that's your run. We know that it simplifies to 1/3. We know that's going to go to 1/3 because they tell us that. So what would we do here? There's a couple different ways to do this, but what would you think to do? What's one way? Just shout out. It's okay if you are not 100% correct. Okay, Tish, how did you get 7? Okay, one way is to cross multiply, perfect. Or you can multiply top and bottom by 7 so that these guys are equal. And then there's your answer, 7. Now, I like how Tish said to cross multiply, so let me show you that way. If you say that they have to equal, you've got 3x is equal to 21. Divide both sides by 3, and you get 7. I actually like that way. Really, really nice, Jessica. Thank you. Okay, and I don't know if Tish, you did it that way, but that's how Jessica did hers. Good job. So they're going to ask you different questions with slope. These are just kind of thought-provoking ones. All right, now, here's the formula that we were talking about. Slope is rise over run, or you can use this formula, subtract your y's in the numerator, subtract your x's in the denominator. Okay, so we're going to go over a couple of examples with that. All right, so here's a perfect example. They're giving you 2 points. They're giving you 2 points. You do not have to graph it, but if you want to, so it's a little bit helpful, you certainly can. What I would do if I were you is write down the formula every single time. Why do I say that? It's kind of tedious, but why would that be helpful?
It's just easier to get the numbers right.
Yeah, that's a good idea. Yeah.
When you can look at which one is which.
Good. And so if it is helpful, label this as my first point, and this one's my second point. So that's why you have 1s and then 2s. So I'm going to just call on you guys. Derek, help me out. What would I put in my numerator? What's one thing I could put in my numerator? And go ahead and unmute yourself. That might be a little bit quicker. And if go ahead.
-5.
Derek, Stacy.
Can you hear me?
Yeah?
Okay, good. All right, can you repeat the question one more time?
Tell me what you put in the numerator.
The numerator? For y2, you'd put -5. And
Minus.
y1 is 9.
Okay, what about the denominator?
X2 is going to be 3, and the other -6.
Okay. Now, if you don't have these written above, and I'm not just talking to you, Derek, is it as easy? I don't know. So if you want to write those on top every single time, that might make it easier. But let me give you a hint here. If you start off with this for your y, then you have to start off with that guy for your x. Okay, so you start off with that y, you have to start off with that x. All right, so let's go ahead and simplify that then. -5 minus 9 is -14. 3 minus a -6 is actually +9, correct? Can you simplify that any further? Not really, and don't write -1 and 5/9. Not for slope. Don't write mixed numbers. Slope is always a relationship to rise over run. So you need one number for a fraction, one number for the denominator. Okay. Could we have done this a different way? Sure. What if we said this was the second point and this one's the first point? Could we? Sure. So if I did it backwards and I started with 9 for my y, what would I have subtracted off then? 9 minus -5 over -6 minus 3. Now look what happens. You get 14 in the numerator and -9 in the denominator. So you get the same answer, right? But now I just see that -9 is on the is in the denominator. Technically for me, I would accept that because we're dealing with slope. Okay, because we're dealing with slope. How did I come up with 14? What's 9 minus a -5? Right, okay, that's okay. That's all right. So now, what these really are negative than 14 over 9. So if you have a negative on the outside, it either gets applied to the numerator or to the denominator, but not both. So with slope, if you have a negative on the outside, it either applies to the numerator or denominator, but not both. So what does this actually mean? If you have a negative in the numerator, it really means to go down 14 and to the right 9. Over here, this really means to go up 14 and left 9. Well, how can that be the same? How can that be that same? I'm going to show you. -6, 9, let's just approximate. There's -6, 9, and 3, -5. If I were to connect these 2 points, would you say that that slope is positive or negative? Just looking at the graph. Slope positive or negative? Negative, right? It's going to be negative. So what these are saying is, I can either, let's do this one in blue. From this point, I can go down 14 and right 9. Or I could go from this point up 14 and left 9. So either slope, whether the negative is in the numerator or the denominator, you can get from one point to the next. Get from one point to the next. And if you keep doing the blue over and over again, down 14 and right 9, you're going to get the other point down here. If you were to keep doing the green, you're going to get in the next point on your graph over here. Change the colors to red if that makes sense. We're going to do another one. Change the color to red. Okay. Let's look at, okay. On this is a homework question. This is a homework question. Number, I don't know if it's 11 or not, because every year I kind of change my homeworks around, but it's probably a close to a homework question. How am I going to figure out this slope of this question? There's 2 different ways. I want to hear your guys' answers.
Use the points marked on the graph.
Very good. Let's do rise over run. Slope is rise over run. Tell me, are we going to get a positive answer or a negative answer? Whoa, we're going up from left to right. So it's going to be positive for this problem. We're going up from left to right. So if we go with this and go up how much? Up what? 2? And run, we're going to go to the right how much? What is it? 4? 1, 2, 3, 4. Good. It's kind of hard to count sometimes. So your slope would be positive 1/2. So that's what you would write here. Positive 1/2. Now, could you have gone a different direction? Yeah? What if I went this direction? What would you say? I'm going to go that and that. What direction is that? Okay, but, all right, duh. Okay, let's just focus this first one. What am I doing right here? I'm going good. Down 2. So my slope is -2. That's my rise. Run is left 2, so that's negative 2. Oops, negative 4. Left 4. So what's negative 2 divided by negative 4? Still positive 1/2. Still positive 1/2. So you have to be careful. Your slope is still going to be the same answer, but how you look at it on the graph could be a little bit different. Green is up and to the right. Purple is down and to the left, but the slope is still going to be the same answer, right? Okay, there is a different way. There's a different way to find slope. Now, I don't know if I would do this, but you could possibly figure out what those points are. That point is 3, 1. Tell me if I'm wrong. And is that point -1, -1? Is that right?
Isn't it 4, 1?
Nope, because this is 0, 0. We had to go over 4, but from 0, 0, we're going to go right 3, up 1. Now, you're right. I forgot. I couldn't tell who asked that question, but if you look at the green arrow, we're going from -1 to +3, so you are going to the right 4. So if I happen to find the points, then I can use my formula, right? And this would give you the same answer. So I'm going to do 1 minus a -1, doing my y's, over 3, my x's, minus a -1. So you get 2 in the numerator and 4 in the denominator. So you still get a positive 1/2. So depending on what you think at that time, there's different ways to do slope. Question? Okay. Now there is another way to find slope. So go ahead and write this down. This is pretty important. Slope-intercept form. Equation of a line. Let's say it right here. In slope-intercept form. So this is an equation of a line. We didn't really work with this form too much yesterday, but this number to the left of x is little m, and little m we just talked about is the slope. So you can think to get slope, it could either be rise over run, or you can use your formula y2 minus y1 over x2 minus x1. Does anybody know what this guy is? Do you remember what B is?
Is it the variable?
Okay, Sarah, y-intercept, y-intercept. And if they ask you for the y-intercept, it's always 0, a number, and that B is your number. Y-intercept. Okay, when you graph, and I'm going to tell this to you here because it's all on one page. When you graph it, you always graph this first, and then you graph the slope from the y-intercept. So you graph your y-intercept first, and then you graph the slope from the y-intercept. Okay, let's look at some questions that you would have dealing with slope-intercept form. Okay. And sorry that you can't really read up here too much. I'll read it off. Find the slope of a line using intercepts and the slope formula. In this case, it's going to be just the slope formula. Okay, so all they want you to do in this problem is to find the slope of this line. What I would do is I would change to the slope-intercept form. Which is y equals mx plus b. That's what I would do. It's the easiest way. So ECOS is telling you how to do that. You're basically solving for y. That's essentially what you're doing. So let's look at what ECOS is saying. So you have 3x minus 4y is equal to 12. So she's subtracting 3x from both sides. Negative 4y is equal to, now, I would put the negative 3x first. You could write 12 minus 3x, but you're saving yourself a little bit of time if you're putting the x first because you want the x first over here. Okay, now, what do I do to get the y alone? Divide both sides by negative 4. Good. You divide by -4. Now, what I like to do sometimes is just divide every term by -4. That's the same thing as dividing both sides by -4. So these will cancel. You're left with y is equal to, what's negative divided by negative? Positive. And a positive divided by negative is negative. So this equation is really the same equation as that, but why do I like it in the slope-intercept form? What's nice about this slope-intercept form? Y equals mx plus b. Why is that nice?
It shows right away where slope is.
Very good. So the slope is always to the left of the x. This is your slope. So on your homework, you would just write in 3/4. That's it. And you're done. Don't write decimals, okay? Don't say it's 0.75. I always want it as a fraction. Good. And then Tish is pointing out, too, if they ask you for the y-intercept, let's just say they do, you could answer that question as well. So your y-intercept would be what? Be careful how you write it. I think they're going to want it as a point. So what would you say? 0, -3. Perfect. 0, -3. So they're going to ask different questions, very good, Jessica, on these types of problems. So what if I now say, now this just says find the slope. What if I say and graph the line? What if I say graph the line now? Well, if you're down here and you found your slope and y-intercept, to graph it, what did I say on the previous slide? You should always graph first. What should you graph first?
-3.
Very good. So you're going to graph that first. So 0, -3 is your y-intercept. It's a point on the graph. And then do your slope from that point. Very good. And Jessica is saying is rise 3 and run 4. So what does that mean, rise over run? What does that mean? Very good. Go up 3 and right 4. So there's my other point. And if they're asking you to graph using slope-intercept, they are going to be looking for those 2 points. They're going to look for this guy first, and then they're going to look for the next point if you're using your slope. You guys are learning a lot today. A lot. Good job. Okay, let's go on. Let's see what other kind of questions they could ask. Sorry, this is the books restore. Okay, now, I think we know how to do this now. I'm just going to show you. Finding the slope of the line and then sketch. The easiest thing to do, in my opinion, is get it into slope-intercept form first. So -3y is equal to -5x plus 15 divided by -3. So I have y is equal to negative divided by negative is positive 5/3 x, and positive 15 divided by -3 is -5. So here's your y-intercept. I'm going to graph that first, and there it is. Then from there, I'm going to do my slope. So they ask you for the slope first, which is 5/3. And then you're going to go up 5 and to the right 3. And then that's how you would graph it. All right. Oh, here's a good one. Here's a tricky one. I think it's number 15 on your homework, or similar to, right around 15. What's different about this equation here? What's missing? Y equals mx plus b. The b. So if I had to fill in the blanks, what could I fill in for b? Plus what? 0. Well, that's nice, because look what happens. This is my y-intercept. I start out there. My y-intercept is 0. And then I do my slope. But what's my slope if it only has one number? How do I do my slope? 3 over what? What could I
Rise 3, run 1.
Perfect. You can always put an integer over 1. So very good. Go up 3 and to the right 1. So there's that next point. There's the next point. And if you wanted to keep going, you go up 3, 1, 2, 3, to the right 1, up 3, to the right 1, and so forth. But they're probably going to look for these two because they're asking you to find the slope and then graph that way. Any questions so far? You guys are doing good. Really good. All right, let's keep going. You guys do that one for me right now. Find the slope of that line. That one looks a little bit different. Go ahead and do that one for me. And I'm going to also ask you for the y-intercept. I'm going to call on you guys, so be ready. Karsten, what did you do? What did you do first? Anything that you did first, Karsten. Okay, divided both sides by 3 because you want to basically solve for y. So y is equal to negative 7/3 x. Okay, so what's your slope? Karsten, go ahead. And then Melody, what is your, nope. Melody, tell me what your slope and y slope is. Okay, negative 7/3. What did you answer, Karsten? Yeah, no, but what was your answer for, Karsten? Yeah, the y-intercept, good. So the y-intercept, you want to just say 0, 0. Okay, perfect. Because you could say plus 0. All right, now we're going to go into, sorry, I had to go through these a little bit more. We were talking about horizontal and vertical lines. We said earlier that if you have a horizontal line, your slope is 0. So it looks like that. If it's a vertical line, you're going to have undefined slope. So that looks like this. Okay. So let's go ahead and look at some of these. Find the slope of this line. So if I say basically solve for y, some people know that right away. What kind, remember yesterday what we were saying, what kind of a line it is? But if you don't remember, we can do a quick t-chart. The y has to equal 3 every time, and you can have any number you want for x, but the y has to be 3. Yeah, negative 3. See, I'm tired today. Sorry about that, guys. So 0, negative 3. 1, negative 3. 2, negative 3. All right, so we know it's a horizontal line. What do we know about horizontal lines? They have what kind of slope? 0. Very good. Now, let's say that you could actually figure this out. If you wanted to use your slope formula where it's y2 minus y1, you could do that. So I'm going to pick these 2 points. Your y is going to be negative 3 minus negative 3 in the numerator. And the denominator, I'm going to do 1 minus 0. So I have 0 in the numerator, 1 in the denominator, so I get my denominator, or my whole answer is 0. Okay. What if I have, and there's just different ways to solve it. What if I say x is equal to 4? If it just wants the slope, some of you could answer right away with, oh, I know my slope is what? undefined. But when you're stressed out on a test and you don't remember, go ahead and draw a picture. So your x has to be positive 4 every single time, and your y can be anything you want it to be. So then when you graph it, you've got 4, 0, 4, 1, 4, 2. There's your vertical line. Okay, so I know the slope is undefined. But you could also use your slope formula. So your slope formula, we're going to go with maybe these 2 points. Your y's are 0 minus 1 over 4 minus 4. So you get negative 1 over 0, and anything over 0 is undefined. So if your denominator is 0, it's undefined. No, Melody. So your slope is either 0 or your slope is undefined. They're completely different. Do you see the difference? If the numerator is 0, then the overall thing is 0. If the denominator is 0, then your answer would be undefined. Did you see the difference on that? Okay, perfect. Okay, we're going to kind of just, they might ask you to graph it, so you have to graph it. I'm skipping here. What if they ask you to graph the line passing through a certain point and it has a slope? Well, even though this is not the y-intercept, you graph that first and you graph this second from that point. So you would go to -3, -2, there's your point. And slope of 1/2 means to go up 1, right 2. So you go up 1, right 2. There's your next point. And I probably am a little bit off. But that's all you would do in your homework. That's all you would do. Okay. So we've got vertical and horizontal lines. We have regular lines. We have positive slope. We have negative slope. Now we're going to compare, or they're going to ask you to kind of compare 2 different lines. And where did it go? There it is. Whether lines are parallel, perpendicular, or neither. This is in the book, but essentially lines are parallel if they have the same slope. Now I'm going to refer to them as lowercase m. So one of your slopes of line 1 is m1, and the slope of the second line is m2. So they're the same slope. Okay, that's parallel lines. Now, on a different slide, they're going to talk about perpendicular, and I wish they would have done it all in the same one. If it's perpendicular, this is really where you're going to look. It has negative reciprocals of each other. So perpendicular, what they really are lines that make a 90-degree angle. That's perpendicular lines. So how do you know that they're negative reciprocals? Maybe here's an example. Slope of line 1 is -2/3. Slope of line 2 then would be, and I would rather say opposite, flipped. Opposite, so if that's negative, this is going to be positive, and then you flip it. And all you have to do is look at their slopes. If they're negative reciprocals of each other, then they're going to be perpendicular lines. Perpendicular lines, that's how you tell. Okay, parallel ones, oops, are going to have the same slope. So parallel lines will go on and on forever, never touching. That's parallel lines. They're going to have the same slope. So when you go through some examples, they're going to ask you whether the line that goes through here is parallel to the line that goes through there. So what I would do is I would figure out the slope of this one, 5 minus 2 over 3 minus a -1. So you get 3 over 4. Be careful you're not doing that too fast. And the slope of this one, 10 minus 7 over 8 minus 4, which is 3/4. Because they are equal, same slope means the lines are parallel. So yes, they are parallel because they have the same slope. Now, if one of them were negative, you could not say that they're the same slope. So they both have to be positive. They both have to be positive, or they both have to be negative. Okay, let's look at a perpendicular one. They want to know if they're perpendicular. Now, here's a different way to do this problem. If it's as an equation, I'm going to call this equation A and this equation B. What did they do down here to these equations? They put them in what? Slope-intercept form. Why do they put it in slope-intercept form? Then you can tell what their slope is really easily. One of them is negative, the other one's positive, so this is a good contender. And then are they flipped of each other? Yes. And another way to tell if they're perpendicular is if you multiply the two together and you get -1. So because the slopes are negative reciprocals of each other, the lines are perpendicular. It's another way to tell. What else? This one is an example of neither. This is +4. This is +1/4. So they're both positive, so they can't be perpendicular. And they're not exactly equal, so they cannot be parallel. So they would say this is neither. Okay, one last thing about average rate of change. They're going to give you some word problems. Okay, it's not that difficult, but I don't want you to get, upset about the numbers. They want to know, in 2003, Americans spent 886 hours watching cable. Using the number for 2003 and the number for 2000 from the graph, find the average rate of change to the nearest, and how does it compare? Okay, so what they're doing is they're taking these points. Oh, and I think this is a bad graph. Let me just look. Yeah. So they're basically taking the numerator, which is the amount of hours, over the denominator, which is your time, and they're figuring out the slope that way. So they're saying 63.5 hours per year. Now, if you look at the graph in example 9, which is back here, this graph from example 9, you can also find the slope, and I think they just said it was +58. If I were to do your rise over your run, 980 minus 690 over 2005 minus 2000. That would give you 58. So they want to compare that to these numbers over here from up there. So they might ask you that. So basically they watch more hours per year from 2000 to 2003. So you might have to do a couple of those. Okay? All right. And I know some of you guys have to go. Yep, I know you have to go. So I'm just saying the last four problems are a little thought-provoking. Go to your book, see some other examples, but keep up with the homework, okay? And you can go to the study plan too, and it'll walk you through them as well. All right, if you have time and can stay, wonderful, wonderful. I'll stay and answer questions. More questions.
Mrs. Parker?
Yeah?
You know how you said